In this video, we're gonna work on some integral that depends on n. So every time we integrate, we have a different value that depends on n. But our aim in this case, we're gonna try to find the minimum of this integral on this interval 0, 1, and the maximum, okay? Since our function is continuous on this interval 0, 1, and this interval is closed, we can find these points exist, the minimum and the maximum exist. Okay, we can get a feeling of what we can what we expect by just doing some drawing of some functions. Okay, so this is an easy idea or a good idea to do. So we have this interval. Let's make it bigger. Let's make this one 1 and this is 1. And when and consider our function f of x as 1 over 1 plus x to the power n. So when x is 0, it starts from 1. And it keeps decreasing, okay? So we see that as x gets bigger, this function is going to decrease, okay? And sometimes it decreases in different manners, okay? So this is 1. There is one specific point here that we need to notice, okay? So here we see that we are crossing this point here, which is very important. This point 1, 1/2, okay? We see that in this point we change the concavity. So if it's up, it's gonna become down. If it's down, it's gonna become up. So here, okay? So this is a point that's very important, and we're gonna come back later to it, okay? So what we can see is that all these points, they have to go through this point 1, 1/2. And therefore our integral is gonna be if we integrate between 0 and 1, okay, we see clearly here that we can see that we can find graphically the bounds that we need, okay? So our function here, its integral is let's say we focus on this one here. So the integral is the one in green, okay? So it's bigger than this rectangle here that has sides 1 and length 1/2, okay? So the integral here, so this area here, okay, this area, the whole area here, so it's the integral between 0 and 1 of 1 over 1 plus x to the power n dx. So it's bigger than 1/2, okay? So we found a lower bound or a minimum. For the maximum, we can see that this area here between 0 and 1 is less than the whole area of the rectangle that has length 1 and width 1. So that means this is less than 1. So this is the maximum. So the maximum area that we can have on this interval 0, 1 is 1, okay? And the minimum area that we can have is 1/2, okay? So this is just using some geometry or arguments, okay? We're gonna use algebra to prove this result. In fact, let's do that. So we have x is between, we're gonna try to find a lower and upper bound of this function, and after that we integrate, okay? So we have x is between 0 and 1, okay? Raising x to the power n, we have x to the power n is between 0 and 1, and if we add 1, we're gonna have 1 is less than 1 plus x to the power n less than 2. These three quantities are positive, so when we flip, we invert these ones here, the order. So it's gonna be 1/2, 1. Now we have our x to the power n. So here when we integrate, so this is the functions, so the integration preserves the order. So when we integrate, we're going to have the integral between 0 and 1 dx, 0 and 1 dx, 0 and 1 dx. So here, this is our n. So our n is going to be between, so here we integrate 1 between 0 and 1. So we have 1. And here we integrate 1/2 between 0 and 1. We get 1/2. And that's what we get. So that means the minimum here, and it does exist because our functions are continuous and this interval is bounded. So that's clear. So our integral is going to be between 1/2 and 1 for all n, no matter which n we take. Okay? And this is using geometry, and here we used integration because we have, if we have a function f less than f of x less than g of x, and we integrate, we still have this less than or equal. Okay, so the integral conserve or doesn't change the order. Okay, so if you have a function here that f is less than g, so this is our f, this is our g, so f is less than g, that's what it means. When we integrate, the area of f is this one, is less than the area of g, which is bigger, which is going to be the one in green. This is logic. Okay, in this interval, let's say a, b. Okay, and that's all we need here. So our result is, we want to always learn with Archimedes notes. Our idea here is to try to find a lower bound and upper bound. And sometimes we use geometry to see where we are going. And after that, we use algebra to prove our result. And I think that's it. If you see or you have any questions, comment. Thank you very much.